Ladies and gentlemen, boys and girls, welcome to TDO. My name is TT, and today's session we're gonna be dealing with sectioning. So now let me just make this clear before we even start that if there is anything that you won't gonna understand here, make sure to go over and start with a class of orographic projection. That is where all the answers are gonna be. Unless of course if you already know the orographic projection, this is where you're supposed to be. So let's shift right over and check out the questions. Before we carry on to the lesson, it is my greatest pleasure to let you know that I've done some research and came up with something specially made for you, which is engineering drawing course for beginners. So if you are interested, there is a link in the description. You can just click it there, which is gonna take you to this page right here. We start from the very basic of engineering drawing, such as reproduction drawing. It's also broken down into pieces, so we're not rushing anywhere, just being fed the knowledge a bit by bit until you get the hang of it. So it's from the very basic all the way up to the more advanced stuff, and then going to the isometric, it's also broken down to pieces. We start by the isometric positioning. We start by explaining that first, and then we jump to the isometric drawing itself, isometric circles after, and then at the end is iso polygons. So these are all the tools that you will ever need in order for you to understand engineering drawing. So if you are interested, you come back to this page after clicking the link in the description. You scroll down to the very end, and then there are packages right there. There is a membership option, and then there is a once-off option right there. So in a membership option, you can pay on the monthly basis and get access to all the curriculum right there. And then on the once-off payment option, you just pay only once, you get the full access forever. It will be up to you to choose the option that you're gonna be comfortable with. But all in all, I would pretty much appreciate your support. Alright, that's it. Now let's go back to the lesson. So right here we have a question that says Figure 5 shows two views of a pedestal bearing drawn in first angle orographic projection. Draw the following to scale 1:1 and in first angle orographic projection: a front view, a full sectional top view on cutting plane AA, a full sectional left view on cutting plane BB. So that's what's required from you. So let's go over and check the what and check the diagram sheet 5 and see the pedestal drawing that they're talking about. So here we are on diagram sheet 5. These are the two views that we have, and they said these views are inward and in the first angle orographic projection. So you already know that in the first angle, the view that is at the bottom is a top view. The view that is at the top is a front view. So now let's start analyzing what? Analyzing the cutting plane. We have cutting plane AA that we are required to use when we're drawing what? The sectional top view, and we have a cutting plane BB that we're gonna use when we're drawing what? The left view. So now let's do the first step. You use the two views, you combine the two views to come up with what? With a 3D object. So this bearing, they've represented it not in a 3D view, they represented it in two 2D views. So what you do is you analyze these two views until you figure out what? A 3D view of this bearing right here before you can get it cut and then present the sectional views just like you require. So now when these two views are combined, this is what you come up with. This is the view that you get. So those two views in a 3D, they present what? This view right here. This is the bearing. This is exactly the component that they want you to deal with. Whereby our front view is represented like this. This is the front view. Go back to the question to confirm. Our front view is exactly like this. So now we have those two hidden details right there, and then another two hidden details that are representing what? That are representing the two holes. So the next thing that you do, because automatically after being able to combine the two views to come up with a 3D view using your imagination, you're gonna be able to spot what? To spot the left view on your what? On your 3D object. So this is the left view. When you turn on your left, this is the front view. And where is our top view? The top view appears like this, exactly like this. Even if you can go to your question to confirm, we have two holes, we have the base, and then we have what? This head right there. So on the front view, the head appears like this, but on the top view, it appears as a what? As a rectangle. So this is the same thing. Also, we have two hidden details that are flowing through that area to represent the hole that passes through there. So now you were able to come up with a 3D view of the object. Now let's start analyzing the cutting planes and cut the object. Right here on the question, they want us to redraw what? A top view. This view right there is an outside top. So they want you to draw this top view after effect. After it's been cut on what? On cutting plane AA. So we have a cutting plane AA right there. We have two arrows that are pointing downwards. So since these arrows are pointing downwards, it means what's behind the arrows after this thing is being cut is what is going to be taken away. So from your cutting plane to the opposite direction of the arrows, that highlighted part right there is the part that goes away. So that's what they want you to do. After that part is gone, how are you gonna see the top view? You have your cutting plane level right there. When that part is gone, simple as that, after the part is being cut off, and then you have your front view, the part that is behind there, the arrows, it's gone now. So now they want the what? The top view. How is it gonna look like at the top after it's being cut like this? You shift to the top view. How is it gonna appear? It's gonna appear exactly like that. So this is what you take and you draw on the space where you're supposed to put what? Your top view. You draw your sectional top view. This is what we call a sectional top view. That shaded piece right there is where the material was being affected by what? By the cutting plane. There it stays the same because the saw didn't affect that part. It didn't cut anything at that part. And then on the next part, it gets shaded again, which means that is where the cutting plane was affecting. That's where the cutting plane was eating material off. It started eating material from this point up to that point. In the middle, there is nothing. It's a hole that goes through. So there's nothing to cut there. There at that point, there's also something to cut up until the end point. So it didn't affect anything from that space and the middle space where there is a hole. It didn't affect anything. Your top view of that base, it's still the same because the cutting plane didn't what? It didn't affect it. Otherwise, if it was passing through there, if your cutting plane was passing directly through there and then the arrows were still pointing downward, it means all the things that were in the upside behind the cutting plane, they were going to be gone. So now that's the only way your base could have been affected. But now your base is not affected because only the head of the bearing was cut. So you take this view as it is right here, you place it on the what? On the sectional top view position using your what? Your first angle orthographic projection skills. So now you are done with the sectional top view. Let's go and figure out the next question whereby you are required to come up with what? With a sectional left view now. So let's go and check it out. We have our cutting plane at BB right there. So let's focus on the arrows. Where are the arrows pointing? The arrows for cutting plane BP are pointing to the right hand side. So it implies that everything that is on the left hand side of the cutting plane, it gets moved away. That is the part that gets taken away, and then you're going to be left with what? With the right hand part of the component. So after this thing is being cut, it means this shaded area is going to be gone because it is the part that is behind what? That is behind the arrows. The arrows are pointing at the right side, so which means everything that's on the left hand side of the cutting plane goes away. So now if that left hand part is gone, you are left with the half part. How is it going to look like now when you look at it from the left view? So since the cutting plane BP passes exactly at the half point of the component like that. So now let's cut it and see what we're going to be left with. It is cut in half. So you go back to your front view. There is the cutting plane BP. So everything was cut in half now, which means the left hand half, it's gone now because the arrows are pointing where? To the right hand direction. That is how you analyze it. So the front will be looking like this now. So when you shift to the left hand side, how are you going to see it? So you shift, this is your left view now. This is exactly how it's going to appear. Now you are no longer seeing the outside view. You are seeing the sectional left view. So the reason why you are seeing diagonal lines that are next to each other like that, we call those lines sectioning lines or hatching lines. Those lines, we use them to highlight the areas that are being affected by the cutting plane. So each and every section that got affected by your cutting plane, you hatch it like that, you highlight it using the hatching lines. So how do you draw these lines? You draw these lines at an angle of 45 degrees, 4 units apart. So it can be 4 millimeters apart at an angle of 45 degrees. So pay attention to this. So the highlighted area is the area that got affected by the cutting plane. But these areas, they stay the same. Why do they stay the same? It's because the cutting plane didn't touch them. Why didn't it touch them? It's because there is a hole right there. So the cutting plane went through, it didn't cut anything. It cut the material from that point to that point, and then from that point, it didn't cut anything. Starting at that point, it started cutting again, all the way to the bottom. There's nothing that can be cut away on that area. That is why you see that surface right there unaffected. So this inner surface right there of the circle, it's unaffected because the cutting plane didn't cut it. Because the cutting plane, it didn't touch it. So even that bottom surface area on the base, it wasn't affected by the cutting plane. That is why it stays the same. You only apply sectioning lines on the area that got affected by the cutting plane. So this is the view that you draw instead of a left view. You draw the sectional left view. The only thing you do, you pay attention to the question. If a question says draw an outside view, an outside front view, you draw the outside front view. Just like they said on this question right here. They said draw a front view. So you see, they didn't say a sectional front view. So if they say just a front view, which means you draw an outside view, you draw the front view as it is. If they've already given you the front view, you draw it as it is. You just copy it and paste it on your answer sheet as it is. And then a full sectional top view. Now, there is that keyword, sectional. It's no longer a full top view. It's a full sectional top view and on cutting plane AA. Once they include a cutting plane, and then they tell you that a sectional top view or a sectional left view, that is where you start paying attention to everything that we've been doing in this session. But if they say a front view like this, you draw a normal front view. A full sectional left view on cutting plane PP, you draw a full sectional left view. If they said draw a left view, you were gonna do what? You were gonna draw the outside left view as you used to do on the orographic projection chapter. You just do that. Or they just say a top view without mentioning a sectional top view and a cutting plane AA. You do what you always do on the orographic projection chapter. You draw the outside views. So ladies and gentlemen, this is sectioning with TT.